CSS positioning allows you to place elements on a page with pinpoint accuracy. It sounds an attractive proposition, but it has some unexpected side effects. In this lesson, I'll give you a brief overview of the theory and some of the problems related with positioning. There are several different types of positioning. They're all controlled by the position property, which currently supports 4 values. Absolute positions an element accurately at specified offsets. Fixed is similar to absolute, except that the offsets are always in relation to the browser viewport. Relative shifts the element relative to its normal position. However, it also plays a vital role in controlling the behavior of absolutely positioned elements. Static disables CSS positioning. The only time you're likely to use it is to override another style rule. 4 properties specify the offsets for a positioned element: top, left, right and bottom. These properties tell the browser how far to offset the element on a particular side. Normally you set just 1 or 2 of these properties. Positioned elements can overlap each other, so you can also set the stacking order with the z-index property. This expects a number. When 2 elements overlap, the one with the higher z-index appears in front of the other. So that's basically all there is to CSS positioning. You set the type of positioning, absolute, fixed or relative. If you want to move the element from its default position, you set 1 or more offsets, and if you want the elements to overlap, you set the z-index. It all sounds so simple, but there's a big catch. Positioned elements are removed from the normal flow of the document, and they occupy an invisible layer in front of the other content. As a result, they don't interact with other elements. You can't flow text around a positioned element or give it a margin, because it's treated completely independently. Another feature of CSS positioning that you need to take into account is what's known as the containing block of a positioned element. This determines where the offsets are measured from. In the case of fixed positioning, it's always the browser viewport. With relative positioning, it's the element's position in the normal flow of the document. However, with absolute positioning, it's more complicated. The containing block is the nearest positioned ancestor. In other words, if an absolutely positioned element is nested inside another element that has its position set to absolute, fixed or relative, the offsets are calculated from that surrounding element. However, if no such element exists, the page is used as the containing block, and because you've got no idea how big the browser viewport will be, it causes major problems with layout if you're not careful. Fortunately, the solution is simple. You nest absolutely positioned elements inside a relatively positioned one, as you'll see in a later lesson. Often, the positioned element will be displayed inside its containing block. In this example, the offsets are 100 pixels from the top and 150 pixels from the left. But don't be confused by the expression containing block. It doesn't constrain where the element can be displayed. It's quite common to use negative offsets to move the positioned element outside the containing block, as in this example, where the top offset is minus 500 pixels. The containing block is simply the point from which the offsets are calculated. So that's the theory of CSS positioning. The remaining lessons in this chapter show how it works in practice.